That's right. You remember.
Goes off.
Yeah, exactly.
All right, just because I have to, we're going to show you the lovely safe harbor statement. Basically means don't hold anything myself or the lovely Gerald Wenzel says to you against us today. So what are we talking about, Gerald?
Cloud native data management, basically how data management has changed in the cloud and what we can do now.
All right. Well, historically, when we were building applications, developers would build large monolithic applications using one single data store. So all the apps would share that one database or data store.
The biggest problem with that was when we added new applications that perhaps wanted to store more data or needed the data in a different format, that always caused some frictions. We had to change the schema, we had to coordinate with other applications and so forth.
So that has led to an alternative approach to application development, one where we have a separate database for each of the individual services that we're trying to develop.
But the databases, they were all specialized, so each was there for a specific data type or data workload. So we have graph databases, we have JSON databases, we still have relational databases, key value analytic, and so forth.
The goal was to create services that are completely independent, that are using the best of breed databases for each of those workload types. was about to say the next bit.
Sorry, guys. I mean, it should be fun, right?
Yeah.
But so for each single purpose database, though, that we have, we essentially create fragments in the overall data architecture. So as from an individual application, we don't see this, right? And actually, that's exactly what we want. We just want to care about our piece of the information. But for the overall company, actually, we just put data in more silos or data fragments.
And because each of these single-purpose databases has their own unique APIs, perhaps lingo, or even transaction processing model, there's no standardization across them. Did you just blow the next line?
Yes,
Okay.
I blew the next
So
line.
there is no standardization across all the different best-of-breed databases.
Now, this is really important because each single database, they're not the same, obviously, right, as there's purpose-built databases out there, and that essentially means they also have different operational needs. And again, this is not necessarily something that we as developers care much about, but actually overall that means that for each new database that you have to bring in or that you bring in, you have to also bring in the unique management and operational skills with it. So like each database is backed up differently, each database is secured differently, and so forth and so forth.
So, and the other thing that can be tricky is I've done my best of breed. My documents are in one database, my relational in another. Perhaps I've got spatial and graph, as you said, in a different database. Now I want to get a holistic view of all the data that I've got. Trying to propagate data between these different silos can be incredibly difficult, and it can lead to great delays in order to be able to deliver that type of answer to the business, as well as just data diversity. We may end up with stale data in some of the databases because of our ETL processing or the movement of that data has been delayed.
Right, and as I said before, right, each database is secured separately. Actually, security is foremost these days, right? The thing with databases, if you have a security breach, that usually means you get hold of all the data or majority of the data. And as you have those different databases in, you have to apply those policies over and over again, and you have to have people actually knowing what data is stored inside those databases, what needs to be secured or doesn't need to be secured, and so forth. This causes a lot of more overhead, potentially even to the point that you don't even know that there's sensitive information in a database where you thought there wouldn't be anything in it.
The other key to this, and I know we seem to be belaboring the point, but stay with us, we're going to get there. The other big issue with having these best-of-breed databases means that we're going to have different tactics for keeping them highly available and scalable, because each one is going to have a specific way to do that, and that's not going to be shared universally across the databases.
When we actually move towards the cloud, look at what's happening in the cloud, we see something of this or the very same happening there as well. Essentially, as we get more and more cloud database services, we see a lot of different proprietary database services out there that you can use only in that one cloud provider. Just like the same issues that you have in-house, if you want to move from one database to another database, or in this case, want to move from one cloud to another cloud, not only do you have to migrate the data to a different database technology, perhaps altogether different database technology, but you will also have to change your applications and change the API calls that you're using, because as Maria said before, we don't have necessarily standards on top of those proprietary databases such as SQL.
Yeah. So integrating these fragmented databases to create a complete, available, secure, and scalable solution is incredibly complex and is custom made for each one of these environments. So even though you may have managed it in one scenario, you're going to have to re-implement a custom solution for the next one.
So what are we trying to do is to work on a multi-model database, a database that can actually gives you or simplifies your overall data management. So just imagine what would happen if you can have a database that not only does your traditional workloads, your OLTP, your analytics, but actually suits or fits well with your next generation workloads, so especially microservices, IoTs out there, machine learning, and so forth. But also allows you to store more than just one data type. So rather than having to bring in a new database for each data type you want to deal with, whether that's okay, we want to store JSON now, we need to have a JSON database, or we want to store relational, we need a relational database, and so forth. Have one database that actually allows you to just store all this information once with one set of APIs based on standards and so forth.
So what multi-model databases are out there today?
So actually, this is nothing new, and it's quite exciting what we see now that as people come to the conclusion, having 30 different databases for 30 different workloads sounds great in the beginning, but somebody actually has to maintain and run those. We see that more multimodal data or more databases converge naturally into multimodal databases. This is not only something new for Oracle. This does this since the mid-90s with object support back then, and moving on from there. But we actually see the same trend now happening with NoSQL databases as well, that they start to reclassify themselves as multimodal databases, as the examples out there that we have there. The question is a multimodal database really the best that you can get? Is it really as good as those single model databases, those purpose-built databases, or the best of breed databases? And this is...
Well, so don't take our word for it. Gartner has ranked Oracle first in all 4 categories from their operational data management use cases. So whether it's transaction processing or analytics, whether it's processing data in motion, or whether it's the distributed data, sorry, I always forget the 4th one. Regardless of what you're trying to do with the different data types, different data strategies, they've ranked us #1 in those.
Right, and also actually the Gartner also has a Magic Quadrant for analytics. I always like to say we store data to afterwards read it and make sense out of it. In the analytics Magic Quadrant, you actually also see that Oracle is the leader in both axes in terms of execution and vision ahead as well. Because really, if you have seen the keynote earlier today or yesterday, we want to give you a platform that lets the data work for you.
So, but Oracle isn't a database that was designed for the cloud. So is it going to work there or not? Well, we think it is. We think it is with the Oracle Autonomous Database that's going to give you the world's first self-driving database. That means Oracle automates all of the kind of common, more mundane tasks you would typically do to deploy a new system. So it's the provisioning of that system, the configuration of it, the management and monitoring of it, as well as the patching and tuning of that system automatically for you, allowing you to simply load your data and get on with your application development. It is going to make sure that it's nice and secure. All of the data will be automatically encrypted. It's secure from both external attacks as well as any malicious internal users, as we take advantage of our own database vault technology to keep the Oracle administrators out of your database. It also wants to make sure that it's self-repairing. In other words, it can heal itself from any kind of potential downtime so that your application can continue to run against that database. Speaking of auto-tuning, one of the nice features about the Autonomous Database is the fact that it'll automatically create indexes for you. As you develop an application and begin to run some of the workload against that, the system will monitor what's going on with that workload, determine whether or not additional indexes could be created to improve performance, and then verify that if those indexes existed, not only would they be used, but they would actually improve the performance. So a test executes all of that. Once it's been verified to help, it'll automatically publish those indexes to your application and improve the performance for you. And it's not just during development that this goes on. It'll go on through the lifetime of that application, continuing to improve the performance as the data volumes perhaps change or the access methods change. And it'll even go in and clean up after itself. So indexes that had been originally created that are no longer necessary are going to be automatically cleaned up for you, taking the onus off of you guys to try and have to tune the application.
So now we're going to go in and show you a little bit more about the Autonomous Database and what we have done. There's 5 key capabilities that we want to demonstrate to you now. Following these slides, we want to show the rapid provisioning, how you can very quickly instantiate an Oracle Autonomous Database. We want to show you the capabilities of REST enabling your data by default. That's really, really nice out-of-the-box functionality that you have, that you just get REST APIs to access and deal with the data inside the Oracle Autonomous Database. We're going to go into the self-scaling part. The Autonomous Database is smart enough to figure out that it can scale itself if needed, if the more processing power is required. Then we're going to have the easy cloning. And last but not least, we show you the built-in development tools as well. So next generation cloud development tools that will help you build on top of the autonomous database.
Right.
Did I get this good?
You did great. So now we've talked all about it. Let's show you it in action. It's far easier to believe when you've actually had an opportunity to see this thing in action. So the first thing we're going to show you is just how simple it is to provision a database. It's going to take me just a few minutes to walk you through. I'm going to use the UI, but all of what I'm about to do can be done through APIs as well. So we're going to start here on the home page of the Oracle Cloud. I could use one of these shortcuts or quick actions to do it, but I'm going to show you the old-fashioned way, up to the hamburger menu on the left, and I'm going to pick Autonomous Transaction Processing. That's going to open the console for the Autonomous Database. And what we're going to do is we're going to go up to that big blue button and say we want to create a new one. First thing I need to do is give it a name. So I'm going to call ours a retail DB, because that's the demo we're going to show you in just a second. I need to give the database a name also. So the display name is just for the console. So I'm going to call mine retail DB. Then do I want transaction processing or a warehouse? I'm going to go with processing, and I'm going to go with the serverless configuration. Next, how many processors? I'm going to go with 2. And I can go all the way from 1 to 128 terabytes, but I'm just going to go with 1 terabyte. I could enable auto-scaling at this point, but since I want to give you a scaling demo, I'm not going to do that. I'm just going to do the last thing now, specify the admin password. Oracle has very strict rules on this. You see them in red underneath the box. Once you meet that criteria, the warning goes away. Then I'm just going to bring my own licenses rather than pay for licenses included, since I work for Oracle, but you do get that choice. And then bang, I ask it to create that autonomous database. And you'll notice there that it's instantly begun to provision that database for me. Where you get returned to is the console for that specific database. It's got general information there about that database, how many CPUs, what region of the cloud it's in, what storage. At the bottom of the page, you'll see backup information. The autonomous databases are all automatically backed up for you on a nightly basis. 60 days worth of backups automatically kept for you as part of the service. You can also take a manual backup. So if you're making changes in the app code and you just want to make sure you can get back to where you were just in case anything goes wrong, you can take a manual backup right before you do that upgrade or change, so that you have that point to come back to. And it should just take, oh, there we go. Now we have an autonomous database available, ready for us to start connecting and loading data. As I said, everything I did there, as well as the controls that you saw on the UI, starting, stopping that database, terminating it, provisioning a new one, cloning, anything I want to do with it, can both be done through the UI, but also through APIs and the CLI commands.
I'm impressed.
I did it all myself.
So now that we have an autonomous database, you can see really you just get a new database in a couple of seconds, minutes or so. We want to show you actually some of the capabilities that we have with using different workload or different data types and this REST enabling feature. So this demo actually, as we just called it out before, we have a retail database. Essentially, our demo here is we are a coffee shop and we want to load JSON payload of coffee orders from around the US into the autonomous database. And because most of the coffee shops around the world tend to have iPads or similar devices that happily send REST calls over HTTP, we're going to REST enable that. So it's not the only way you can connect to an autonomous database. You can still use your regular drivers that you have today. But actually for those internet IoT kind of workloads, REST lends itself very, very nicely towards it. They don't have to do any additional tests or any additional steps, I should say. Let's kick it off. So in SQL Developer, I'm connected to the retail DB. The first thing I'll do is I'll actually create a REST service. So create a REST module here, go in there, give it a name. I provided a prefix that will be in the URL and make it public. Next thing, I specify the URI pattern order here. I give it the highest priority so that this gets stored immediately. Here's the URL that will essentially be on the cloud. Click Finish. This is all I had to do to enable a REST endpoint. So now we have the REST endpoint there. What we're going to do next, we put a handler there for post. We're going to send data in, so we just did that. And now the post will execute a simple trivial insert into our orders table that has only one column in, which we actually store the JSON in. So we will see here is that the values will just say column body, which is a predefined bind variable for the entire payload of the REST call. We save this, now we are live. That is it. The REST endpoint essentially, so SQL developer showed us with localhost 8080. We of course not on localhost, we on the cloud. And we have the REST endpoint up there on this URL. So you see this is the autonomous database URL, and then this retail DB is our database that we have created. Orders is the prefix, and order is the URI pattern that we have. So we can now just send REST calls to that URL on our autonomous database, and we'll just load JSON into the database. Next part of the demo that I'm going to show you is actually just an IDE, a little Java program where we do exactly that. It just takes that REST endpoint and then just sends those JSON data into the autonomous database. So we go ahead, we're here in IntelliJ, have the REST endpoint there that you saw before. We just have here underneath a little bit of code that essentially sends this HTTP post. We see there we pass on the REST URL there. We have the data, which is coming in just into the function, it's just passed in. And then we have essentially the output there. We say that we send JSON up, and then we have the output there. If it's successful, it will tell us that the data has successfully been posted. Otherwise, it will fail. Let's spin it up. We should see here data successfully posted in just a minute. And there we go. Indeed, the data is successfully going into the autonomous database.
Cool. So now that we've got our application connected to the database, data's going in, we may want to scale that database. Now you get two options. What I'm going to show you is what manual scaling looks like, but you do, as you saw when we provisioned the autonomous database, have an option for auto scale. So as you can imagine, scaling with the Oracle Cloud is pretty flexible. What you can do is you can scale either CPU or storage. There's no predefined must-use shapes. So you can choose to just increase the CPU or just increase storage or increase both. You can do it through the UI, which is the demo I'm going to show you, but you can also do it through any of the APIs. So you can do it just for month-end processing. If you know that that's coming right at the beginning of that job, you could ask for more resources. Or you can turn on auto-scaling. With auto-scaling, we're going to increase the number of CPUs and the I/O throughput of your autonomous database based on your workload. So what we do is we ask you to specify a base CPU count. So let's imagine I pick 4. For those 4 CPUs, that's what I'm paying for most of the time. If for some reason I get a spike in my workload and I start to max out those 4 CPUs, Oracle will automatically scale me up to 3x of that base. So I can go from 4 all the way to 12 CPUs fully automatically, and only when I need them. As soon as that workload drops off, I go back down to that base of just 4 CPUs. And you only pay for the additional resources during that spike. When we spike up from the base to the additional CPUs, whatever you use underneath that little spike in the graph is all you're going to pay for. And you can see all of that through the console, or you can request it, what was the CPU count at any point in time on my autonomous database. But let me show you a quick example here. What I'm going to do is we're going to start it. The demo moves pretty fast, so I'll just give you guys the outline before we start. I'm going to kick off a swing bench workload. If you're not familiar with that, swing bench is just a workload generator tool that's available on dominicgiles.com. And what it's going to do is it's going to insert and manipulate JSON documents within our retail database. Once it gets going, we'll realize that we're somewhat CPU bound, and then I'll show you how we can scale and improve the performance of our application. So let's jump into it. So as I said, I'm going to start by starting the swing bench workload. I'm going to start 128 users on that. So that's what you're seeing there is just them coming online. The 4th column is the one I want you to focus on. That's the number of transactions per second we're able to get. All 128 users are now connected and are generating a workload. But if you look at the transactions per second, it's fluctuating quite considerably. And that's an inkling to me that there's something wrong on the back end. So I'm going to open my database monitor to try and find out what's going on that database. And so if I look at the database monitor, basically I seem to be not CPU bound I am CPU bound, but what actually is taking all of the capacity is the scheduler. I have too many processes on just 2 OCPUs. Remember, I only have 2 CPUs, so I'm going to go up to the scale up button there, and I'm going to change it from 2 to 8. Now again, I could have enabled auto scaling at this point, but let's say we don't. What you'll see is that those additional CPUs instantly begin to be provisioned to my database. If we come back over to Swing Bench, and I don't know whether you can see it or not because my little clicker doesn't seem to be, but there is a little line here that says that's the number of CPUs. We're going to see that line jump, there we go, from 2 to 8. And what we'll see then is that that 4th column is actually going to show a much more consistent result of about 32,000 transactions a second. Very consistently, now that I have enough CPU resources, I'm not waiting on the scheduler anymore to be able to process that workload. So as I said, you can do that scaling manually, as I showed you through the API or through the UI, any of the APIs, or you can just simply click the button at any point in time on the console and request Oracle to automatically scale that database for you. Anytime after that, we'll automatically adjust the resources as needed based on your workload. All right.
So Maria, now that I have my JSON data going in my retail DB, I would like to actually deploy a nice little app on top of it. Would you allow me to just use the production database and deploy my app on it right away? Or
you want to develop a new app in production? Yeah,
it's called agile, right?
We're not that agile here. Let's make sure production stays production. So what I can do with an autonomous database for requests like that come in is I can instantly clone that database fully online. So I can create a mirrored copy of that database for Gerald to begin the development of his application. And in fact, I have 2 choices. Sorry, I thought I had a slide on it. I guess I don't. I have 2 choices. I can create a full database clone. That means all the data, all the metadata gets cloned into a separate autonomous database for Gerald. Or I could just give him a metadata-only clone. So he'd get all the schema information, all the users, everything would be there for him, but it would be empty. There'd be no production data in that clone. How do I do it? Super easy. Again, I go to the console, I go up to Actions, and I say I want to create a clone. I get a choice between the full clone, as I said, all the source data and metadata, or a metadata only. I could give him one that only had the schema and the users in it. But since I like Gerald, I'm going to give him a full clone. Next, I need to give it a different name. And now it defaults to say that it's a clone of the production environment. But we're going to develop a reporting. So I'm going to call it report dev. Again, I need to give it a database name. I'm just going to stick with the same name I gave for the console. Now, what's interesting is he can have a different number of CPUs on his clone than I have on production. Remember, on production, we had 8. He's only going to get 1, but I'll give him auto scaling, so he can have up to 3. He gets a new password as well. Definitely make sure it's a different password to the production environment so that we're not going to get cross-pollinate. But once I've got that, again, I just decide what kind of license I want. I'm going to let Gerald bring his own. And instantly, that clone begins to provision. How long the clone takes to provision is more determined this time by the size of the database. So a brand new autonomous database provisions pretty quickly, but a clone will be dependent on how big the production or the primary database that you're cloning is. As you can see there on the console, auto scaling has been enabled. If the bill comes in and it's pretty high because Gerald has been running amok and running all sorts of workload on this environment, and I want to turn that off, I can go up to this scale up and down and turn it off for him. So with that, we now have a clone for you.
And you can see how much Maria trusts me. She gives me all the data, but only 1 CPU. Or 3. Is there a question, actually?
Yes. When you clone the data, do you need a consistent copy? How does that affect the production?
Did you guys hear the question over there? Or should we? Yeah, okay.
So it is a point-in-time copy. at the moment. So the clone is a point in time as opposed to a refreshable clone where we'll keep it in sync. So he gets all of the production data as of that moment that I created the clone. The production environment continues to execute, and there's no impact on that while the clone is being generated from it. But it is not kept in sync going forward, if that's what you meant.
But it's fully consistent to the point in time. So as the cloning happens, you get the data
as of that moment.
That time.
Yeah.
So not any dirty clone or something with in-flight transactions or something. That's fully consistent. Right, so we have a couple of really nice development tools out there since a long, long time. You may or may not have heard of Apex, our Application Express utility, which is essentially, I always call it the UI of the database. Oracle has this fantastic capability to allow you to just have a web UI on top of your data. All you need to know is to write SQL. So we're actually going to leverage this now in this demo where I got my reporting database. I want to write some my reporting development database. I want to write some reports of all those JSON documents, all those orders that we got in, right? Essentially, somebody sooner or later will ask me, hey, how much money did we actually make? And that's actually very, very easy to do. Now, this is not to show that, instead of writing Node.js front-end application or so forth, you should use Apex or vice versa. It's actually more to show that for simple things like that, you don't have to write a front-end application. It's actually out of the box, and it's browser-based, so everybody can use it, right? So it's not a either or, but it's just to show you that you have the capability. A lot of times, we tend to spend a lot of effort and developers' times to write code for simple or relatively simple tasks. So in this demo, I'm not going to go through how to build an Apex app. I'm just going to show you how easy it is actually to export that Apex app from a reporting development environment and then just deploy it into the production environment. And I have a slide in there.
Do we have a demo in there?
So I actually think this is out of sync, but anyway, maybe not. Are you sure this is? Let's see quickly.
You don't have your Apex
I don't
demo?
have my Apex demo.
All right, chat among yourselves while I get Gerald's Apex demo.
So see, I knew that this was like, and you have to forgive us, Maria was like tied in with many other keynotes from her boss, Juan, and other stuff. So we kind of did this demo when we had or this slide deck when we had all the other stuff going on as well. We'll bring it up in a second. So the one slide that we just saw there is like, or the things that we have walked through is like, why is autonomous so interesting? Because it gives you one database that you can use for things like relational data, for your JSON data, for your graph data, for your key value data. You can store all of that in one database. So that's great. That's the multimodal database. We have seen other databases doing the same thing out there as well, right? Like Cosmos DB is a similar equivalent from Microsoft, actually, right? But what's the difference with autonomous database? It's actually an Oracle database. So that means, number one, it's fully compatible with your existing applications already. You can just point them to an autonomous database. The really, really nice thing is it's standards-based. So everything you do, you can either do via things like SQL, of course, or REST calls, or Sparkle, or whatever you have. While other technologies, such as Cosmos DB, actually you will have to write your applications towards the APIs Cosmos DB provides. So that's nice, and there's nothing wrong, but it essentially ties you into it, right? So if you ever want to use something else, you need to go into your applications and change the API calls. With autonomous database, you don't have that. And then you have the nice aspect of the autonomy. Like, how often have we had situations where somebody calls up and says, or the developer goes, oh, my query is slow. And yeah, because you didn't have an index on column X, right? The database since a long, long time, the Oracle database since a long, long time has been really smart about those things, right? Since a long time, you could actually run a tuning advisor that tells you, hey, I just looked at all your SQL queries, and there's one really slow, and if you would have an index on the column, it would be running much faster because that's your where clause predicate right there. But it never, ever enabled that. If we can get to a stage in general computing where we no longer have to worry about those tiny things, like, okay, somebody needs to log on and create a table, an index, how hard is that, right? It's like if we can just get the database to go like, hey, you already know what workload is going on. Hey, you already know, what you should be doing to get a better access path. The cost base optimizes all those calculations in it. If we just do it, then it allows us to actually spend more time on developing applications on providing value to the business rather than kind of going through the hoops and chasing those things. And at that point, I always say in my earliest life, when I was a developer, we ran into those rollback segments issues that we had all the time. So when Oracle still had this old kind of thing of how to do undo, and you would run queries, etc., and boom, you would just get a random error, and it would be like, yeah, okay, snapshot tool, whatever, kind of cryptic error that didn't make much sense to me. And essentially, the DBA had to go ahead and create a file on the file system in the right location, whatever, right? It's like one command to execute. It's like, well, luckily, years ago, this all changed, and Oracle was smart enough to just go like, hey, you know what, I just, create more space myself for this, and I don't have to get to that. And this is what we're trying to get to. If we can actually way too much time in development is spent with tuning systems, with root cause analysis and so forth, if we can actually make software smarter to do this for us, then we can focus more on writing code for the business, or writing business logic, and so forth. Now let's hope yes, we have it. So here we go. That's the demo. So we log in into our what is this? Yeah, retail DB into our application. I think it's the wrong one, frankly, because we're already on the retail DB. So this is the part where we show you the Apex app, essentially, where we had once more. So we log on into the database that we have, right? This is just Application Express. We have an application there that we can run. Once we hit this run, the URL on top will change. That's publicly available to everybody. And all we do here is we just show you a sum of the JSON data we have. We see some nice elements of Apex going back and forth. In this case, we grouped by city as well as state. And actually, all that happens is like it's SQL queries on top of JSON data that we have loaded into the autonomous database.
Yeah.
I can see that next time, Maria,
you're going to be in charge of the slides.
When you do one slide, I gotta go myself.
So, yeah,
but I'll give you that slide.
All right. So as we've showed you over the last 40 minutes or so, some of what you can do with the autonomous database, and that it's so much easier for developers to utilize that rather than having to rely on the IT department to provision and manage and monitor a dev environment for them. What's really nice about this is if we've got a development environment and we've decided that we're done with it, they can be easily terminated or trashed straight from the UI or from an API, so that as soon as we're done with that environment, it just disappears and we no longer have to pay for those resources. You can continue to clone and again trash those clones whenever you don't want them. You can stop and start them as well. So if you know that as the developers, they'll come Friday at whatever time they're done, they're not going to be really using those environments over the weekend. You can reduce cost by stopping those databases on a Friday night. Again, you can script all of that, so you can use the APIs to do it rather than having somebody sit there and through the UI having to click through all of that. Then you can also have a job Monday morning that cranks all those databases back up again, allowing you to save on those resources over the course of the weekend as well.
Perfect. And with that, we have a couple of minutes left for Q&A, I believe, right?
Did you want to offer people some of your stickers?
Yeah, there we go. Yeah, so if you want a sticker for your laptop, if you do that, like I don't have my laptop out, I'm a little bit more diverse than Maria, full of stickers. If you want a sticker, an XE sticker here that we still have, feel free to grab one.
Just in case you don't know what XE is, do we want to spend a second just to
explain
what Oracle XE is?
Go ahead while I try to open this
Oracle
thing.
XE is our free version of the Oracle database that is available for you to download off oracle.com. It's a developer instance, so no additional licensing required for that. It's got pretty much all, not quite all, but pretty much everything you would probably need from the enterprise version of the Oracle database. But
right.
It's specifically for developers. You are limited on the size of system that you can run it on. So if you're thinking, well, hey, now I can run production on this free software, there is a gotcha. There is no support. And you are limited to how many cores?
2 CPUs, 12 gigabytes of storage, and 2 gigs of RAM. It's actually also quite nice if you're not a developer to just use it and test out some features if you want to. As Maria said, there's a lot of EE features in there now in 18c XE. So if you just want to like, oh, hey, I want to try this new feature that Oracle has since a long time, download XE, just give it a spin. Almost everything is in there. Hopefully you've also watched all yesterday Larry's keynote, right?
And you stayed
We
all
have.
the way till the end?
Right. Everybody has watched Larry's keynote, right?
Oh, good. Okay.
Yeah, okay, I was also more like this. He also, though, announced the free tier for developers on Oracle Cloud, and this is also a really important and right step into the right direction for those of you who haven't watched the keynote. Actually, starting yesterday, we give you an always free tier on Oracle Cloud as well. This is not it expires after 12 months, you have to start paying us like other clouds provide it. This is not a 30-day trial like we used to have. We give you 2 autonomous database instances up to 20 gig that are free forever as long as you keep using it. You get 2 VMs, OCI VMs, 2 compute nodes that you can use, and you get networking, you get up to, I believe it was 50 terabytes in and out and stuff. This is a really substantial offering compared to what other clouds have out there. Number one, in terms of that it's always free, we'll never charge you for it. It won't terminate after 12 months or something like that. And number 2, in terms of resources, we are actually the only cloud that gives you the flagship database cloud service available for free altogether for that long or forever.
And don't forget, you also have your $500 of free cloud credits. So all of you have been whitelisted. So when you go to oracle.com free and sign in and sign up for an account, you'll actually, unlike the regular Joe Blow who gets 300, you guys are all been whitelisted for 500. So although the autonomous database, you can get 2 of those. You could try a data warehouse and a transaction processing on the free tier. There are other services that are not part of the free tier, and that's what the $500 credit is, to give you an opportunity to play around with those in conjunction or independent of your autonomous database. You can actually experience a lot of the Oracle Cloud for that $500. So don't leave it on the table. Don't leave it in Mr. Ellison's pocket. Take advantage and utilize that additional free credits. With that, we're happy to take any questions people might have. Yes, sir.
You didn't mention anything about users or your REST services. Can you restrict who can run what services?
Yeah, so the REST APIs, you can essentially just control it via OAuth 2, right? So it's like right now what we showed there before, this was a public REST service, so anybody could actually fire off queries towards it, but you can control, number one, who can call the REST service and authenticate, go via HTTPS and send HTTP authentication through it. And you can also, on the database side, control actually who can write what REST services, right? Because as you have one database, I may have just one schema. Schemas are great, although in the microservices world, we tend to forget about them. I may just want to say, well, actually, Maria is allowed to write REST services against her schemas, but I'm not. And by default, everything's turned off, right? So it's like security first. So if you get an autonomous database, you have to first enable it. So this is exactly what we didn't show the part in the demo. Yes. Yeah. You can also, in the REST call itself, you could also restrict to the MIME types that you send through. So actually, I didn't do that. I had it in the Java code that is at application JSON. I could do the same thing on the REST call so that you have an additional kind of who can call it and what data can be sent to it as well.
Can you go back in and modify the Java that was generated, or?
I'm sorry, the first part I didn't catch.
So you went in and typed in a begin insert. So of course, what good is that if it already exists? You'd have that exception you'd want to handle. Do you modify the Java code, or do you have to write everything in SQL and use Oracle exception handling versus Java exception handling?
That is essentially up to you, right? It's like it depends what you're after. If you have your REST call that is called by many, many different services, as usually it is, you will probably want to deal with those exceptions on the backend side of things. But if if you go like, hey, here's just a REST call, I deal with all of that myself, you can do that as well. It's entirely up to you or your use case in that case.
And you can still use all the standard things from the Oracle database, user privileges to limit things, primary keys to make sure we don't end up with duplicate data, and all of that can be done through that way, or as Gerald said, you can put it in your own code too, whichever you prefer.
It's also important to point out that we actually also allow you to auto-generate CRUD operations on REST. So you could just click on a table and say, okay, give me the equivalent REST operations, get, put, post, and so forth. And we basically enable CRUD operations if you wish to do so. So you don't have to write any SQL at all if you just want to enable for somebody to load data into a table or get data out of a table. Yeah, you can do more sophisticated stuff. So if you want to, for example, provide this report that we showed via REST endpoint, nothing stops you from writing whatever SQL you want to write, and that SQL just gets executed when you have a GET request towards REST and gives you the payload data back.
Okay. Anybody else?
So on the Oracle XE, any general time frame for the 19C version of it?
To be determined right now. So we continue producing XE, but right now we are not quite sure when exactly we will drop the next version of XE, but it will be coming.
Yeah, the current version is 18C, so for anybody who's looking at it, it's 18C, so it's pretty current.
Yeah, should we mention the 20C non-CDB stuff while we're here?
Yeah, go on, break that.
So for who is running on 12C upwards today? Okay, not that many. For those of you who haven't gone to 12C yet, you may or may not be aware that we have introduced a new container database architecture, a CDB architecture with pluggable databases. This is what Juan was talking before about in his keynote. For those of you who are on 12C already, usually, so when we introduced this all in 12.101, there was this huge of, oh, we have to do migration to this new architecture, et cetera. It wasn't actually never really a migration, we just have to start using it. We deprecated what we now call non-CDB architecture, which is our traditional 11G architecture that you have, or basically no container database, pluggable databases. With 20C, this will be de-supported. So the only choice you got on 20C is the container database architecture. It's just a different architecture. It doesn't cost you anything more. You just have to get used to the concept that there's a container database and a pluggable database. Yeah.
And with that, we'd like to thank you guys very much for joining us today. We hope you enjoy the rest of the show.
Thank you very much.
Thank you. I'm so sorry.
That's okay. It was all right. Feel free to grab stickers if you want them.
Bring home your very
you. everybody? Okay, can you guys hear me? Hey, welcome to this session. I know it's a lunch break, but I appreciate people that are coming here. So first my name is Bernard de Traversat. So I manage the engineering team at Oracle. So I've been kind of working on Java for a number of years. I will not say too long because I think it's a great technology. Safe harbor, which means don't assume that everything I'm saying will end up in our product here. So kind of looking at where we are driving this platform. In short, I'm kind of looking at four main areas. Security, there is no sense to have a platform, even if this platform is fast, great, all the functionality, if this platform is not secure. Also, we believe from in the age we are, it's important for a developer platform to be open. So there is a sense for the customers that are using a programming language or platform. They get a sense that hey, it's a free. Also, it's a place where we can engage people to help develop the platform. So it's not just us as well, and Oracle that is developing the platform. Next, compatibility. Clearly, enterprise and a lot of people have put significant investment over the last 20, 25 years on the Java technology. So I think it's very important for us, Oracle being the steward of the Java technology, that we ensure that his investment can be used in future release of the platform. And so we are spending a significant amount of time every time that we are releasing a new release, or if we are introducing new features, to ensure that the new release will be compatible, so you can take an existing app and hopefully run it without any modifications into a new version of the platform. Now, of course, there is cases where we have to break compatibility, but typically, we do that with care, and we understand the impact to our developers. Moving forward, I think in order for Java to continue to remain as relevant as we can in the cloud, it's kind of important that we try to make this platform much more nimble. Density, efficiency are very important metrics in the age of the cloud when, as an enterprise, you may be running hundreds of thousands of Java services, and at the end there is a cost. And so we want to ensure that the cost and the efficiency of running a Java workload is as low as possible compared to native. And of course, the last one is performance at scale. But also, I think that in the world we are living now, there is more demand for near real time, where predictability is not just that you can run this service fast, but can you run this service with predictable SLA, so there is no chaos when there is slow responsiveness. You may lose customer, you may lose transactions. So predictability at scale, I think, is going to be something that's going to become more and more important moving forward. So going back to where we were, so we had this release cadence up to JDK 9 that was kind of roughly every 2 years, but of course every 2 years end up to be every 3 years, because when you start to plan those massive major releases, there is a lot of stuff that we are putting in it. Some cases there was features that were not completely done, and so we had to kind of extend the GA date to make room for completing those features. And so with the community, a few years ago, we kind of started realizing that this release model was not in tune where developers are today, as well as the people moving into the cloud, where here the speed of adoption, the speed of updating is much faster. So we came up with a 6-month release. We felt that 6 months was a good balance between getting the right rate of innovations to our developer, as well as for us, understanding the complexity of this platform. We have to support a very large number of hardware as well as operating systems. So it's kind of essential that when we release, we run through our regression testing, and I can tell you that's million and million and million of tests. And we need to analyze those tests, making sure that everything is right. So 6 months, we felt was the right, time frame. Then, clearly, those releases every 6 months are, towards innovations, toward our early adopters, people, developers that are on the fringe, that are interested in uptaking the latest and greatest. Those releases, also what we did was we kind of changed the license, moving away from the BCL license and moving to kind of this dual world of, hey, we give you a 6 months release under a pure OpenJDK GPL plus ClassPass exception that you can use. Everybody understand, the GPL plus ClassPass exception. That's our Linux. So it was some kind of way for us to kind of make things, much more easier to our customers. But doing the 6 months releases, we do also understand that, enterprise customers need, more time potentially to be able to update, and 6 months may be too fast for them. And, enterprise customer, they need stability because in some cases they have legacy services. They don't want to invest. They don't expect to go and move those services faster than where they are. Maybe they're running on 8, and that's fine. They have no intent to upgrade, those services. So that's why that in this dual world, we'll have 6 months releases as well as LTS releases. So we can, pretty much, decided at this point to look at producing an LTS release, every 3 years. So 6 months, 3 years, depending where you are. Clearly we know that many enterprise workload will not be able to go and uptake at this point 6 months releases. And so as a steward of the platform, also as commercial vendors, Oracle is providing commercial support. And as you guys know, there are a number of other vendors that are providing support on those long-term LTS releases. So upgrading, and that's kind of more the part of my talk today, which is kind of realizing that why upgrading is becoming more and more relevant in where we are today. So my sense is that what we have seen over the past few years is this massive cloud buildup, where we are seeing more and more services that are concentrated into a few set of cloud environment. And of course, upgrading and patching become even more important here because the risks are much higher. Interesting, statistics that say that, and you can see that there's been a lot of, breach or malicious, attack that you are seeing in the press, or you guys may know. In many cases, there is a patch that was available for this security, but the fact that as an industry, and especially in the Java, Java world, where we had kind of this model where, hey, you only release every 3 years. You build the service, you can leave it running on 1.6, 1.5, 1.4. Sometimes I'm very amazed. We are meeting customers, they tell us, hey, we still have services running in 1.5. So it's part of our responsibility as a steward of the platform, to ensure that we are kind of driving the entire ecosystem into a place that at the end will enable us, to ensure that Java workloads, are more secure. And then there is also at the scale of the cloud, if you start to have so many different versions, and you enter into this complexity. And complexity to manage at scale, it's where typically you're going to run into problem because it's too complex. You have too many versions. Which version I'm supposed to update? Which other version? So that's kind of something that we need to look at into. So of course why not upgrading? So clearly is that the fear. And that's a fair assessment that there is a fear because something you may break something. Clearly, there is a cost, as we know, and I'm be the first one to acknowledge that if you update something, if you change something, there is a risk that something may go wrong, and it may cost you money. I mean, if you have a banking, if you do transaction, then that's something that will be, very expensive. And then, of course, I acknowledge that from a developer standpoint, it's a work. There is some work that needs to be done. Yes, in some case, we're going to break some API, but that's something that at the end we believe is going to be valuable, and we don't do it, without understanding the risk here. My take, all along, when I'm looking at our software industry, and that's something that, for the Java ecosystem, we need to kind of, help our developers, move in this path. So can we learn from the hardware guys? And the part that is striking to me is that, if you go back and look at a data center, 10 and 20 years ago, there was wire everywhere. There was a lot of mess. And then clearly, the hardware guys have done a fantastic job in terms of, moving at scale into, putting system, hardware infrastructures into a place that is much more, that would say, consistent, uniform, much easier for them to manage at scale. Okay, so can we learn from it? And here, basically, the low and the complexity theory just tell you that there is two key areas: uniformity. Uniformity kills, complexity. So can we be at a place, where in this cloud, you don't have to run, 20 different versions of Java. It's only one or a few, much smaller than what we have today. And modularity, the ability is to ensure that there are clear encapsulations, where if you touch one services, there is clear set of API, clear set of contract, between those various components. So that's why that, part of the march and what we have done with the module system was to start to move into this place. I know it's a painful place because, if you look at the complexity or the issues that people are running, with migrations, from 6, 7, 8, yes, there is places where we are removing API. Yes, there is places where we are bringing behavior on those APIs, but typically, we don't want or don't do it, as often as we feel that it is very important, when we do it. But the vast majority of the issue it is that we are using, internal APIs. Those internal APIs were not part of the, public API that are either governed by the Java SE specifications or by the JDK. And so clearly, when you start to use internal APIs, there is a high chance that we may, change them. And if we change them, then now you have to modify your code. So the big innovations that we introduced in JDK 9 with module is this ability to have now a clear, expressing, this clear contract in terms of public API. Public API to the world, public API to a few set of modules that I'm trusting, and I'm working with those modules. So by the time I'm releasing a new version of my module, I will ensure that the dependency, internal dependency have been addressed. Or APIs that are only used within the module. So, going back, when we started to talk about the 6-month release to the community, there was clearly, a sense, around, well, you guys are moving too fast. And that's, I can understand clearly, the first reactions that people had around the fact that, hey, 6 months is too fast. Then, at some point there is this acknowledgement, and clearly what we get is that, well, some people say, hey, I don't want to hear about it, putting kind of their hand in the sand, and not really kind of, acknowledging, but in some way starting to realize that maybe the world is changing. And the fact that, I can't leave my service running for years on an older version of Java, is not acceptable anymore because the risk with vulnerabilities are too high. And then we kind of started the second wave, which is what I will call the realities, that yes, well, I know there is some work, but at the end, it's not that bad, right? And I think now, clearly, it's too early to tell, but clearly, we are starting to see, the part of the ecosystem that are, using, more modern stack, starting to embrace, the 6 months release because they are starting to see the value of getting innovations, starting to get kind of this rhythm, which is already in the cloud. In the cloud, you tend to have, continuous integration, continuous deployment, where the tooling that we have today are much more advanced than what we had 10 years ago in terms of updating, a workload. So going back also into the 6 months release, So clearly, 6 months release has much less content than a 2 or 3 years release. And in fact, if you kind of look at the number, I think the number are fairly interesting here. I went back and looked at the number of overall JEPs, you guys know, major features, smaller enhancements, and issues. We have roughly around 32,000 issues that were delivered in JDK 9. JDK 11, 4,400, kind of one of the first 6 months release. So we moved to the 6 months release cadence after 9, so we have 10 and 11. Then you move to 12, we are at 3,400. The interesting part it is, we just did the check on 13. We're also roughly at 3,400. So in some way, you start to understand that there is so much work that us Oracle, since we are driving most of the development in OpenJDK, there is kind of a chunk of work that get delivered within a 6 months period. Then the interesting part, I went back and to JDK 8 and look at the first 6 months release that went after the G of 8, which was 8.2.20. And you can see the content of 8.2.20 is some way very similar to our 6 months releases that we're delivering now. So while there is this perceptions around the numbering, which is, well, 8.2.20, yes, it's only minor versions, so it should be easier for me to uptake these versions. Well, you go back and look at 12, 13, it's the same amount of content. And then I went back and looked at 11.01, which is the first CPU releases after 11, 1,200 fixes as well. So while I think that's part of the help here and something that we need to continue to educate the ecosystem and the communities is to kind of understand that the 6 months release don't look like our old major releases. They are much easier. They should be much easier for you to uptake. The content is much, there is much less content, and also I think they are much simpler, to uptake. Also, getting into a place where you have much more predictable, every 6 months something is coming. We can start to move the ecosystem into a place where they know this stuff is coming, they know the date, it's a predictable, work that needs to be done within each enterprise to be able to uptake those releases. Another thing that I think is, it's important to capture it is we are in this place where we now need to look at the 6 months releases as continuous innovations, continuous evolution of the platform. So it's not just like we are putting one release that bring the wheel, bring the car. It's kind of this evolution that is moving here, and sometimes I can hear people saying, okay, well I look at the kind of the main features in JDK 12. It's only like 5 features or 6 features. JDK 13, we have 5 features. There is not that much content, but I think it's very important that we remind people that when they are looking at 13 or 12, they need to look at where they are and look at all the features that have been delivered incrementally, on JDK 9, 10, 11, 12, and 13. So kind of going back into, and I will do that quickly, going back to 10. In 10, there are some, very important features or improvement that we did to the platform. Docker support, making sure that the JVM is interacting in terms of resource control, resource management with the Docker containers. Clearly on the language, the march that we have, it is to make the Java language as much approachable as we can with the var. Also, we introduced in 10 our next generation's compiler, which is a Graal compiler, a JIT compiler written in Java. It's right now available on 10. It's an experimental feature. So it's important, in fact, that we start to get people turning the flag, see how the Graal compiler is behaving, and sending us feedback. On 11, a lot of work, from Intel around optimizing, intrinsics in the compiler so we can get better crypto performance. We delivered the Java Fly recorder. We certainly, we believe is going to be an important feature for the entire ecosystem to be able to get the right level of observability at scale with lower performance cost. That's a significant feature. And so when you get at 13, you would say, well, I don't see JFR, but JFR was introduced in 11. Then clearly, a lot of work on the GC side, both on G1. Then we introduced our ZGC collectors, which is kind of, position it on the high end, going after the petabyte heaps that, a few years, we have hardware vendors building petabyte system. And we know that in the large scale, near real-time analytics, machine learning, response time, that people are going to want to have a lot of data and process all this data in memory, because this is going to be too slow. And then delivering that at an extremely low latency. So for the first time, kind of breaking the trend of as you increase the heap size and the post time, go up. 12, more work on G1 to kind of, making sure that if you don't use all this memory, you can work, the VM can work with the container and the operating system to be able to manage the physical memory and share this physical memory in some case where if you're not using all the heap for other processors. More work on startup. Clearly we understand that, in the age of microservices, startup is very important. And the part for us of startup, I'm kind of looking at it in two places. It's, code warm up, basically warming up your code for fast startup, which is great. But the even more important part is warming up the data. Because at the end, what startup, really mean for many of our customers is the first time you have the abilities to process a first transaction. And that's kind of at the end what we need to sort out. That's been warming up the code, great, but then we warm up the data as well. So 13, well, very pleased to announce that we just released JDK 13 today. It's available, so if you go to the Oracle JDK, you will find basically the 13 release. So in short, looking at 13, well, some new features on the language, text block. So you guys remember when you have to write, those, various string commands, you have to go and play with a lot of cut and plus. So here we have a much simplified part, and that's part of what we are doing with Project, Ember. Part of the direction here it is to kind of continue to make the language more approachable. We have to acknowledge that there is a new generation of developers that may not have the same patience that some of us have around programming. And so we need to continue to do whatever we can to make the language much more approachable. And less verbose, so you have to write less, be able to get something running quicker than we have done in the past. And that's what Project Ember is going after. Switch expressions, kind of the same line, so you have all those cases. If you forget the default, how many times you forget the default case, and then you have a bug here. So again here, making more concise, get the expressibility, much more, nicer for a developer. AppCDS, so clearly, the model and the usage of AppCDS, which is key features in terms of enterprise deployment in the cloud. That's mean if you have multiple instances of the same services, we are marching into a place where we want all those JVM processes to be able to share as much content, static content, so you don't duplicate, the informations, and more importantly, memory usage for all those JVM processes. So before 13, the usage of AppCDS was first you had to run, get some profiling informations, dump this data of the class that you were loading, and then create an archive, and then basically the next ring run or multiple run with this archive. So in 13, we are trying to make this feature much more approachable, where by default, you can run these things. The first time you run, we'll generate the archive. Underneath, we'll create basically the archive, and then the next time you run, you will be able to leverage this archive and get performance improvement. The performance improvements are fairly significant. So here I'm kind of showing kind of the trend, from so the red is 8, the gray is 11, and 13 is a ping. So you can see that, there is continuous improvement that we are making in AppCDS. Also, one of the key advantages of AppCDS, it is that if you have already an existing instance running, all these classes, metadata classes, that you need to use, that basically the next instance of the JVM need to load to be able to start your application is already warm up. And in memory, using the same data structures that the JVM is using. So you can see that you can get significant startup with AppCDS. Also in 13, we are providing a new re-implementations of all the socket and server socket layers. A lot of technical debt here, but also I think the most important part of this new implementation of the socket is to prepare for Loom and Fiber and continuations. It's clearly, in some case we are seeing significant performance. It's going to depend on your workload. There is, better use of the modern NIO capabilities that we implemented a few years ago that get us, a much cleaner implementations for the network stack. We're also delivering a significant amount of performance on the G1, especially around the memory heap usage in terms of providing a much sophisticated way to track object link between regions, something that is very important for G1. G1 is basically dividing the heap in different regions. Object need to maintain references across regions. And so we had a way to track this information that was not as efficient as we can. One of the engineers came up with a very smart way to do that. And the key advantage is you can reduce significantly the memory usage, which at the end reduce the number of post time that you need to do. And then continuing to advance ZGC, providing better capabilities to again, manage physical memory between the operating system, the container, and the JVM, and provide performance optimizations around the new read barrier safe point that ZGC need to implement. So if you now kind of look at the performance drive from 8 to 13 or 11, you can see that this is kind of one of the standard industry benchmark. You can get a fairly significant performance improvement, especially on this benchmark, because typically on this benchmark, getting a 1%, 2% it's a massive achievement because those benchmarks have been optimized for years and years. So finding kind of the delta that will get you a few percentage is very hard. So you can see here that going from 8 to 13, you can get a significant almost double-digit performance and improvement on the throughput side. Another benchmark here, where here you go from up to 40% throughput improvement. So think in terms of the cost. You have this workload deploying a fair amount of instances on the cloud. You're being charged for usage of all those instances in the cloud. 40% reductions on your bill every month is something that is non-negligible. The work that we have done also on 11, and that's something that I think, again, I want to rehash the point that please, let's make sure that people don't look at 13 without looking at 11 and what we have done on 11. I mean, there are significant memory improvement, footprint reduction that we have done that are very, very significant. That means 6x, it's massive. Another improvement is around startup again. So we are continuous to look at the way we can reduce the number of class loading, be smart in the way we are doing startup. Clearly also we are kind of looking with the Graal VM team around static compilations that will give you other dimensions around startup. If you need extremely low startup, but then we still have to look at how we can warm up the data, which is going to be a very interesting problem that we are starting to look at into. On the GC side, looking the improvement, comparison between G1 and ZGC, ZGC is really, amazing. So we're looking around like, half a terabyte heap, which I understand. It's been a lot of workload will not be at that scale, but I know also a lot of workloads will go beyond that scale. So you're getting, here's kind of reversed, lower is better. So you get, reduction to 20% without losing a significant amount of, transactions, throughput. And we now have, some customers that are running, ZGC up to, 16 terabytes. So that's kind of, exciting for us, and continue to see kind of the drive towards, pushing the limit in terms of scale. Another thing that ZGC is providing you, it is extremely low, post time. That's a few milliseconds, which is kind of order of magnitude of any other technology that we are seeing in the marketplace. So beyond 13, you're going to continue us, to see, a string of innovations. Clearly Project Vana, I think you guys know, you heard about it, what we are doing there. Clearly with, Project Loom, I think that's a project that I'm very excited because I think it's going to have, dramatic impact on the abilities to scale existing services. We know that, an area where, Java is kind of dominating, within the enterprise and within the cloud is those high throughput, services where there are millions of users that are accessing a service here. So the abilities to compact much more and have much higher level of density, because typically, a lot of the issue when you scale the service is less around getting enough core on the server. It's always memory, especially for Java. And so here we can reduce by an order of magnitude the amount of memory that is used by maintaining a context, moving from thread to fibers. Thread will be, in the order of megabytes, where fibers will be in the low end of kilobytes. So, significant improvement. And then from a programmability, standpoint, moving into a place where, yes, asynchronous I/O, asynchronous, programming is fantastic, but at the same time, it's way too complicated. And moving into a place where you have continuations, where the VM itself will manage all the continuations, understanding, when to resume, fibers will provide a much simpler model for our Java developers. On the language side, as you have seen in the keynote, more very interesting features like, records, fields type, pattern matching will have a significant impact in terms of enabling to move in and out data in a much, I will say, way where the Java type system will understand the data that is moving out. And that's kind of the foundation for me to get the next level where we can look at how we can warm up data inside the JVM and enable, much faster startup that we have done in the past. Another project, I need to mention is also the work we're doing on Panama, tremendous progress. I expect that, there will be an initial delivery of Panama over the next 12 months. But that's an area that is very important, especially in the big data, machine learning, and AI, because clearly, there are a lot of core engines, especially in the ML as well as big data, where those libraries are native because they've been written like that. In some cases, they are native plus assembly. So people have been spending years and years to optimizing to the bone those matrix multiplications. And so what we wanted is to enable Java developers to be able to leverage those native libraries and be able to do that in a much simpler way. So you don't have to write all this very complex and error-prone GNI code, as well as providing you much better performance. So the cost to go from native to Java will drastically improve. And why it will improve? Because instead of having to copy data back and forth between the native environment and Java, we'll provide the abilities to access native structures directly from Java without having to do copy. So kind of in summary, I think we are now in this place where we're delivering the adoption releases, early adopters, driving innovations every 6 months, and then the LTS releases. The part where we need the help on the 6 months release, from my hand is around making sure people know that we are producing early access build every week. So in fact, we are releasing 13. We have had early access build on 14 for the past, 3 months. So you can go and start testing it. And by testing it, you can just send us, a quick report. Everything is fine, or, we find some issues. And so we need kind of, getting, and we are starting to see, a number of third-party maintainers that are really embracing, this 6-month cadence. And I can see that, by the time we pushed the first early access build of 14, the same day, we had a few library maintainers that say, hey, I already have a pipeline on my CI that is testing with an early access of 14. So kind of get people to start to move into this model if they can. And clearly, if you have an enterprise services that is more legacy, that you want to take more time to maintain, something that you don't want to because there is more complexity, more risk for updating it, and you need to take more time, then we do have the LTS releases. And of course, Oracle is providing you commercial support on those LTS releases. We have, at the end, a significant team that has all the expertise across all the different area of the VM libraries to be able to help our customers ensuring when they're running into issues, or also to help, tuning their workload if needed. We'll continue to value backward compatibility. We feel that, and we're starting to see that to some level, that once people go over the hump of 9 and get into the 11, 12, 13, things get much easier. Much easier because they start to have shifted their mental model and know that now they can go and update every 6 months. But also because we have better boundaries between what we platform providers or have the abilities to modify, because we need to modify in some case, internal APIs, versus what are the public API that are the contract between we platform providers are exposing to our developers. And then, of course, if you want to stay on LTS, it's perfectly fine, and we fully understand that there are a lot of workload that will not be able to move that fast, at least for now. So in summary, I think we need to continue to deliver innovations, show that the Java platform that is becoming even more pervasive, continue to drive innovation. So developers that are coming in and looking for platform are looking at Java no more with, okay, this stuff has, is 25-year-old. No, there is basically a lot of innovations in terms of, state of the art, platform, virtual machine implementations, as well as programming language. I feel, I've been in the Java team for a number of years. I think that the roadmap that we have over the next, 12, 24 months is the most exciting. I mean, looking at, Vala, Loom, Panama, and Ember, as we are pushing more and more the envelope, is something that is very exciting. Exciting for us engineers, because at the end, the engineers love to write new capabilities and put those capabilities in the hand of developers. And knowing that developers are very excited and ready to uptake many of these new features is something that is very important. And finally, we have an open source project that basically we have contributions from virtually most of the major software companies in the world. Please come in. I mean, it's a place where it's perfectly fine to learn. One of the things that we are doing we're in the process of transitioning the infrastructure for OpenJDK to GitHub. That hopefully will make the approachabilities for developers that are used to contribute in open source projects through Git and GitHub much easier, kind of lowering the bar for at least people to come and help us. So please join. Clearly there is a lot of work, more work that we have people right now. Okay, and as Q&A, I think we have a few minutes for the Q&A. We'll let you with this cartoon images. Question? Sure.
Testing. Okay, great. Paul Weber, San Diego Java Users Group.
Yeah.
Could you help me understand or clarify about the long-term support and the 6-month release pattern? Does the long-term support, so like JDK 11, get some bug fixes and patches, but just not new features of JDK 13 and 12 and 14 and 15? Or is it stationary? And then what is there any updates to LTS 11 that will happen in the next 6 months or a year before the next LTS?
Right. So the initial model that we have, of course, you wish you had, black and white model, but the black and white modality is that, the sense that we have, and when we talk to our customers, is that on the LTS releases, most customers are not interested in new features. What they are mostly interested in is ensuring that I get security updates, ensuring that, if there are crashes, robustness issues, then make sure that those robustness or crashes issues are being addressed. Also, in some case, and that's where now we get into these gray areas. For example, on the LTS, you're going to see a new release of an operating system. So by the time we GA11, for example, on the Mac, you were on the older version of the Mac. Now you have a new version of the Mac. So clearly, we need to ensure that the new update releases run on the latest version of the operating system. Is that a new features or not? So clearly, that's an area. Another areas where we will, consider backporting features is security. For example, crypto protocol. Clearly, we started to ship, 11 on an older version of the TLS. Now we have TLS 1.3. It's essential for us that we ensure that workload that are still running on 8 or 11 have the ability and access to TLS 1.3, because it would be not responsible for us to leave our developers that are running on 8 on an older version of TLS. So it's not going to be no. There will never be features that are being backported to 11 and 8. And of course, you can see that the bar to backport to 11 is kind of here. The backport to 8 is way up. So there is kind of the sense here. The part sometimes that people they don't fully realize it is that every time you backport a new features that was developed on the latest mainline, which is in that case 14 now, there is a tremendous risk. There's a tremendous risk because the VM is extremely complex. It's an area that you see sometimes people say, well, okay, yeah, I see there is a patch or a feature that was introduced by Oracle on 13. Oh, let me go and backport it to 8. And this is a risk. And a lot of enterprise customers are going to look at this thing and say that I don't really need these things because my service is running. I don't want to take the risk of doing those backport. Now I can also see some other entities that have more interest around staying on 8 because they may not have the discipline in place to be able to uptake, or maybe they have. It's going to take them years and years to be able to come in a place where they can uptake new releases to want to invest more on 8. But my sense it is, as an ecosystem, we have the choice as an ecosystem. Do you put investment into the future or do you put investment into the past? And we need to kind of find the right balance. And right now we are within this transition. So clearly there are a set of services that can move that fast, may have interest into access to new features that are introduced on 13, but I just want to raise a flag here. And in terms of support, what we do is that Oracle will support the 6-month releases. So support is kind of orthogonal in the sense that why enterprise look for support? They want a relationship. It's not just around getting a stream of bugs. It's have access to the engineers that are working on the platform. And in some case, yes, they have a crash, they need a patch, and one thing that we're offering our customers is the ability to deliver a patch before this patch gets delivered into public releases.
Yeah. So just a follow-on question, is more curiosity. You had a slide up there with the additional under the cover fixes like 3,400 into JDK 13 and some number into 12. Is there a percentage of those that are put into the LTS, like 11?
Yes, yes, absolutely, absolutely. So what we do it is that, and that's kind of the difficult part here, and that the expertise that we have, which is that every time we fix something on 13, we have to ask ourselves, the question it is, should we backport this fix into 11? Should we backport this fix on 8? And this is a tremendous, it's not easy. I mean, you may say that, oh, well, we should backport, all those fixes in 11. No, I mean, you have to look at the complexity. Also, we understand the different dimensions from complexity, also the risk that are being, and as well as the testing coverage. I mean, how do we feel confident that we have enough testing coverage to make sure that we are not introducing, further regressions into this area? And that's where, it's take time. You have to have done it for many years to kind of get a sense of, what makes sense or not. Okay, I just saw the sign that, we are done. I appreciate, you guys coming here during your lunch break. Thank you very much.
Did you add me to the stuff?
I don't know. You want it? You want it?
I submitted the session for you.
Yes.
I don't
You
know
want
why.
to do?
Well, I did.
I make that pretty much time. Oh, we can hear the mic is live, which is good as well. So welcome, everyone. Thanks for coming along. I appreciate there is a lot of good choice at this conference, so I do appreciate you spending the next 45 minutes with me. We're going to be discussing continuous delivery with Docker and Java. I'll introduce myself in a second, but to set a bit of the context, I've been working in this field for 4 or 5 years, I guess, with both the technologies. And I think the perception is a bit different than the actual reality of the situation, yeah? The kind of pitch is we have our monolithic apps, we carve them up, we put them in containers, we ship them, and we are good to go, yeah? The reality is many of us have Tirefire applications, yeah? I know I've accidentally written my fair share of Tirefire apps in the past, things that evolve out of control, a couple of frameworks in the mix, all going a bit wrong. The problem is when you combine container tech with stuff that's not quite good anyway, let alone good for container tech, what you end up with is literally Tirefire in a container. Yeah, this is not a good look. One sort of good thing is you'll notice the first responders in the bottom right there. This is what we refer to as DevOps in our industry, and this is how I make my money in the UK putting out fires. Yeah. In all seriousness, today I'm going to give a high-level talk of some of the good things I've seen with containers in Java, some of the bad things, and some of the things which I definitely recommend you don't do, mistakes I've made. Try and avoid them. I'm sure we'll all make our own mistakes. We're destined to do that. But I always like to learn from other folks at conferences not to repeat sort of their mistakes. Stand on the shoulders of giants. I'm not saying I'm a giant, but I've stood on the shoulders of many other giants at this conference. This is me, at Daniel Bryant UK, on Twitter, on GitHub, on LinkedIn. I've pretty much cornered the market on the interwebs with that name. I have an interesting background, I guess. I was an academic for a while. Java is my native language. I've done a bit of ops. I've done a bit of architecture. I still write a fair bit of Java, not as much as I'd like, in all honesty, but I do a lot of continuous delivery work. I've recently published a book with my awesome co-author, Abraham Marin-Prez, Continuous Delivery in Java. That will go into a lot more depth of what I'm going to talk about today. Today is a high-level thing. Deep dive in the books. The one on the left there is actually free, courtesy of Nginx, the continuous delivery in Java. But containerizing continuous delivery in Java. But the other one's a full O'Reilly book you can get on Safari. If you are interested, these days I'm doing a lot more work in the app modernization space, a lot of stuff with API gateways, with service mesh, with Kubernetes. I work with Ambassador and HashiCorp quite a bit. I work with DataWire, I should say, and I also work with Ambassador and Console Tech from HashiCorp. So if you want to come and chat to me afterwards about this kind of stuff, I'm more than happy to. I'd love to kind of pick your brains on how you're getting on with migrations of apps, old world to new world, these kind of things. But back to the scheduled program, what we're here for, continuous delivery and Docker, yeah, with a bit of Java. Let's refresh ourselves. A lot of the value I add these days is bringing folks together and reminding them of key principles. In the past, I've definitely got a bit excited about technologies, definitely Docker. Got quite excited about Docker, got quite excited about Kubernetes, service mesh, but I realize we're all here for a reason, to deliver value. Yeah, be it actual business value, or if you're working for the government or an NGO, value is delivered in a different kind of way. But in the modern kind of era, velocity and stability is key to organizational success. Unless you're building like nuclear reactors, different kind of thing there. But predominantly, we're trying to get to market fast. We're trying to do it stably. We're trying not to get breached in terms of security. We're trying not to fall over regularly when customers flock to our site. A friend of mine in London, Steve Smith, many awesome books from Steve, well worth checking out, has this great saying, yeah, continuous delivery is achieved when stability and speed can satisfy business demand. What that kind of says is you know your context better than I ever can. If you can create a pipeline with whatever technology, Jenkins, GitHub Actions, whatever you want, if you can create a pipeline that meets the speed and stability requirements of your business, you are winning. Probably time to look at another problem if you've got that kind of thing going on, rather than making it gold standard. But I see many folks not quite internalizing what continuous delivery is all about. And I'll go into some more depth in a minute. But I'm sure many of you have seen discontinuous delivery, where you can't go as fast as the business wants, or if you do, stuff falls over a lot. I've been there, yeah, for sure. Really key thing, stability and speed. Remember this as we go through the talk. This is really quite a key thing. Apologies, probably a little bit small, but hopefully nothing new. This is a standard Java build pipeline. standard Java delivery pipeline. I'll point through some of the things. So we're coding on our local machines, maybe got IntelliJ spun up, whatever. I love IntelliJ, all that good stuff. We're committing to maybe a centralized repo or something like GitHub, SVN, CVS, or CSV rather, or CVS. We're then building, say, with like Circle CI, Jenkins, and in the traditional Java world, we typically push to something like Artifactory or Sonatype Nexus, maybe a jar, war, ear, whatever your flavor is. We then take that artifact, we deploy it onto a QA environment, do some tests. If it works, we push it along to staging, maybe do some more realistic tests. Maybe QA, we're mocking. Staging, we're using sandbox environments, PayPal Sandbox, for example. And then if it all goes well, we push to prod. Yeah. Now, continuous delivery doesn't end there. I'd argue it actually starts there. The key thing with continuous delivery is getting that feedback loop going. Yeah? Are you learning in terms of business metrics? Did this idea we all had actually work? Is it delivering on our KPIs? Is it delivering on our promises to our customers? But also, is there something we can learn in terms of architecture? Is there something we can learn in terms of operational? Are we burning CPU, or are we flooding queues or networks or whatever? To be honest, I'm not going to talk about this too much today because it's a topic in its own right. And many other awesome people like Cindy Sridharan, Copy Construct on Twitter, also Charity Majors, Mipsy Tipsy on Twitter. Both of them talk about these things in a lot more detail than I do, and they do amazing kind of blog posts on this stuff. So well worth looking at this kind of thing. Closing the loop is really critical. But we're going to focus more on the actual pipeline today because that's more where some of the Java stuff, the mistakes I've made, come into it. So the good with Docker and Java, the good is we can Dockerize, containerize. I may use the two terms interchangeably. They're not. Docker is a kind of brand, if you like, of a container tech. Apologies if I do switch between. I use Docker mainly, I'll be honest. But you can Dockerize your dev environment setup. This is quite nice. Docker all the things. I know Netflix, they have quite a complex build chain, even locally. So they put all the things in a Docker container. That's nice and portable. You don't have to pollute your machine with lots of brew installs or apt gets, all this kind of good stuff. Docker enables repeatable builds. Once you've built your jar, put it in an image, done the config correctly, you can crank the handle, deploy multiple places, scale out, all that good stuff. I love my Star Wars, so it's kind of a bit like the clone army in my mind. You can just keep cranking the handle, and out the containers pop. And I'm not on camera, so I'm not going to name any names, but everyone's got that favorite app server they love to hate. Yeah? You can basically seal these in a Docker container. So you don't have to have multiple versions of whatever sitting on your dev machine. You can hermetically seal those kind of dangerous app servers or whatever technology you're using into a container, which I think is really nice. Now, as a technical leader, as an architect, our choices are all about trade-offs. There is never a right and a wrong, very rarely a right and a wrong. It's all about trade-offs. Docker containers have their trade-offs too. Yeah, The bad stuff is kind of like this classic, why is this container image 1 gigabyte? It's just a Hello World Java app. I've got my Go app over here, it's like 20 megs. What's going on, yeah? And, I know I've been using Java for like 15 years or whatever. It's got a bit of a, sort of like a legacy almost of being a bit verbose, being a bit big, and some of it's, fair, to be honest. But there is some tricks we can do to get rid of some of these challenges with size and with resource consumption. The class one, I was like, dinosaurs must have completed their dev test deploy loop faster than me. And I'm not sure, but when you add a new abstraction in the mix, often if you're trying to do that kind of what you're used to with the monolith, where we could literally just spin it up, do some coding, hot reload, see the results, commit to GitHub, and off you go. The dev loop now, if you've got containers in the mix, can be a bit more complicated. Add microservices, add a microservice-like architecture or a loosely coupled SOA-type architecture, you've got multiple components in play. Maybe you've got multiple data stores. How do you now spin all that up and do your testing, do your dev loop? So that's definitely something I've spent quite a bit of time on, and we cover that quite a bit in the book as well. And the classic one I had, and I'll share this at the end, was this Java app runs slow, or it freezes. In Docker. It's fine on a VM, fine on bare metal. As soon as we put it in a container, we leave it for a week, and it suddenly freezes. And I actually had that problem. My team luckily found the answer, and I'll share it with you. And many of the folks have kind of commented on some potential causes of this as well. So there's no such thing as a free lunch, or free beer, or free Coke, whatever you want to take, Coca-Cola, I should say there. The impact of container tech on CD is kind of fourfold, I like to say. We've got our pipeline here. I think it changes like this. So from this to this, and I'll walk through each step here. The first one is now you probably want to install Docker or some kind of container tech on your local machine. Some companies I work with do try and abstract containers away from engineers. I generally shy against that because I think mechanical sympathy, or we as engineers understanding the platform we're deploying onto, we write better code if we do that. Same with the cloud. If you don't give developers access to the cloud tech, they will write bad code, in my experience. I've certainly messed up a bunch of stuff. In the cloud, everything's on the network. You need to understand that. With a container, it alters the runtime fabric. We as engineers need to understand that. So I heartily recommend installing Docker on local machines, teaching engineers, getting them to play with Docker, do their tests. We'll cover that more in a minute. The way we now store artifacts is different. Probably you don't want to store your jar or your war anymore. You want to store the container image. You want to put the jar, the runnable jar in the image, or you want to put the war in an app server and put that in an image, for example. Again, your mileage may vary. I've seen all different types of things, but predominantly and anecdotally, my experience is that now people are committing container images to a registry or a repo rather than jars. Some do both. The way we test now is different. We're going to want to spin up a container image. We're going to want to spin up a container and test it because we can't just spin up something that's going to be deployed differently into production. This is really key. And of course, your deployment fabric, your actual orchestration is probably going to fundamentally alter. You're going to be using something like Kubernetes, Mesos, ECS, EKS, that kind of thing. I'm not going to talk too much about that, but do recognize that, again, mechanical sympathy, you have to understand the platform you're deploying onto. Yeah? For example, with Kubernetes, things are a lot more ephemeral, a lot more transient. So when you're building apps, we've got to recognize that they might be spinning up and spinning down a lot more than they did when you're on bare metal or on VMs. Always remember, though, we're trying to push things down as fast as possible, and we're trying to make it as stable as possible. One of the key learnings I want to share with you, and I'll mention it a couple times with my patterns, is that now the container image is what I call the single binary. And I take this from Jez Humble and Dave Farley's classic continuous delivery book, which is well worth a read, even though it's 10+ years old now. Fantastic book. One of the key advices they give is build binaries only once. Because then if you build it and you test it and deploy it into production, there's less chance of drift of building multiple things and testing them and then building something different, putting it to production. I'll cover some more of that in a minute. But build binaries only once, and now the container image, in my general experience, is the single binary. So some lessons learned. I'll walk through a couple of stages of the pipeline where I've made some mistakes myself. I've seen some mistakes, for example. The first, and it goes without saying even with containers, but make your development environment as production-like as possible. Yeah? I do strongly believe that I can get my dev loop going on with IntelliJ and maybe a Spring Boot app or a micro-profile app, for example. But before I commit that code to GitHub, I will spin it up in a container, make sure the config still works with the code changes I've done, for example, because you're going to be deploying that container. By all means, work really fast in a local dev loop, but before you commit, put it in a container, do your tests. Do use identical base images, and we'll explore the base image concept if you're not familiar with it, but basically, it's the OS within the container that your Java app is running on. I had one project we were working on. I joined it late. The team were using Ubuntu and coding away, all going well. They went to push to production, and the ops team said, we only run CentOS in production. That's what we're licensed for. That's what we've kind of built a pipeline up for. And it totally made sense, yeah? The dev team, unfortunately, had not engaged with the ops team up front. And they liked Ubuntu. They thought it was fine. But we had to wind some stuff back because of some subtle differences with the security config between Ubuntu and CentOS, for example. Dockerfile content is super important. Are people generally familiar with Dockerfile content? Can I have a quick show of hands? Because I talk to all different types of audiences. Yeah, but 50-50, I say, actually. That's worth explaining. So this is really a manifest, if you like. You can think, your classic Java manifest, for example. But here, we're going to bring in some extra stuff, like the from is kind of the base image, the OS, if you like. We're adding an artifact, a Java artifact, a jar. We're exposing some ports, and we're saying on line 4 how to run the thing. Even if you're not familiar with Docker, the kind of syntax there should hopefully speak to you. But that's a very simple Docker file. Like, it gets super complicated super fast in my experience, particularly if you're working with legacy systems. I had one Ruby system I was working on. I think we had 60 lines of crazy bash to get it running in a container, because it used Passenger and it used all like weird database connections and stuff. So there's a lot of choice, and a lot of engineers I work with, particularly in bigger organizations, like they are not operationally aware. And there's nothing wrong with that. They like to write code. They're very good at writing code. They have limited time to learn. We can't expect them to know everything. Yeah, I like doing ops. I've learned it. But your mileage may vary. But there's a whole bunch of things you need to think about here. Making the OS as small as possible for runtime consumption, for attack surface, for security. The way you configure the OS and put the build artifact in there. Do you go Oracle JDK, Open JDK, JDK, JRE? And some of you in the audience are probably thinking, like, JRE, JDK, it's obvious in production what you'd run, but you'd be surprised at what I've seen in my consulting. I've seen literally full-fat Ubuntu images with a JDK running in production before. So you don't want to do that, and I'll cover that in a minute, but I've seen that. And we've got more choice these days. Hotspot, OpenJ9, Graal, Substrate, all that kind of good stuff. Because I mentioned people are often doing containers where their workloads are more transient. They're spinning these containers up, short-lived, and dying. And Java is kind of built of the era where it was running for days, or years sometimes for apps. Now people are looking at things like ahead-of-time compilation instead of just-in-time. They're looking at things like class data sharing and application class data sharing, which George mentioned in the keynote yesterday. And lots of choices. To a lot of engineers, this is confusing. I certainly was when I started. Bottom line is talk to the ops team in your company. Talk to the InfoSec folks. Talk to the platform team. Their operational knowledge is invaluable. And rule number 1 really is that engaging people. I've worked on too many projects where we, kind of didn't engage with the right folks, and at the end you reach massive operational hurdles and political hurdles. Yeah. So engage with the ops folks early on in your company. Better to be difficult up front than difficult at the end is my experience. I mentioned a few times, starting with good base images is really key. Yeah? I'm a big fan of using the OpenJDK stuff. We'll dive into it a little bit more. If you haven't heard, there is some changes around OpenJDK in version 8 and the Oracle thing. I'm not going to go into it. I've said my piece a little bit online. I'm luckily part of the Java champions. Martin Verberg and many other people in the community have got some amazing blog posts out there that clarify how licensing has been changed now with some of the things. I use the adopt OpenJDK build farm to get my OpenJDK binaries. Azul do fantastic work. Red Hat do fantastic work. There's many places you can get your binaries, not just Oracle. Much as I love Oracle, of course. Thank you for Code 1. Just be aware of this kind of stuff. Yeah. So just be aware is what I'm saying of this kind of stuff. We've all got to make money, so I totally get why Oracle have changed their licensing model. But we as engineers have to recognize some of the legal and some of the money kind of aspects of what we do. Get off my soapbox for a second. And now, going more into the technical details. So a lot of folks I see sort of start with OpenJDK 8 image up there, or pick your number, 11, 13, whatever. This is a good start, particularly if you're, say, actually coding within a container. But obviously, it's pretty massive. Yeah, you see the end there, 657 megs. You don't want to put that in production for a whole bunch of reasons, because you don't want to put a JDK in production. But what folks often then discover, a bit of Googling, a bit of interweb searching, is they can use something like Alpine. Now, Alpine is just an OS. It's a very small OS, so we get rid of a lot of cruft. Like that very simple Spring Boot app, which I had previously with 657 megs, with Alpine, and I've also pinned the versions of the JDK. We're using update 181 and Alpine 3.8. I've massively reduced my container size. If I go even more sensible and use the JRE, which I'm deploying into production, just the Java runtime environment, no JDK, I can get it down to about 116. Yeah. And if you use something like Azul Zulu, or there's Project Portola, which I'll mention on the next slide, you can get it down, the smallest I've seen it is about 40, 50 megs. Yeah, so you can get it down pretty small. This stuff is extra work. Post Java 9, you can use JLink to create custom binaries effectively, native binaries. You can, where it sort of compiles everything into the artifact, and you don't even need a JRE on the machine, because it's all there. There's things like Project Portola, Azul Zulu, which do some clever stuff around, because some of the issues with a big container size in terms of an actual container image is to do around the glibc and the muscle library in C. And some technical details, I know a little bit about it. I can point you some more resources if you want to know more, but that's the kind of tricky part. And Project Portola is an open source effort to make that better. And Azul have already got an implementation of Alpine with muscle C, which is super lightweight. You can get there, but whatever you do, please do test. Yeah, this stuff is, I've only seen really heard, I haven't actually worked on, I've only heard of a couple of companies in London that very specialized use cases were trying to minimize super small their Java runtime. It's doable, it's not free by any means. So one of the sort of second questions after the setting up the config is, why is my image so big? Yeah. A couple of tools I'm going to share. If you haven't, but I'm a massive Maven fan. I know it's a bit old school, and Gradle's the cool kid, but I like Maven. So sorry, a couple of Maven examples, because I mainly use that. But Maven dependency tree gives you a nice overview of all the dependencies you've got going on. And if you bring in something, it often brings in lots of transitive dependencies. And it's nice to just understand, could you substitute this library for another one? I've seen a few projects where we're just using some really simple string utils out of, I think it was a Spring library. And it was bringing in pretty much all of Spring for a string utils thing. So we swapped that out for some Apache Commons stuff. So understand what's going on. Same with dependency analyze. You can look for unused dependencies and unused. You've got to be a bit careful. We're trying to pull out, like some folks, we looked and we were seeing unused dependencies in our jar, which we didn't need, but they're actually needed at runtime. So Maven's not perfect in this respect. It's a kind of build time analyze, whereas you often runtime, there's some reflection magic or some other magic going on. But again, these tools will help you understand what is going into your jar. Next tool is super cool, nice graphic. Got to give a hat tip. It was Alex Goodman, not my work, it's Alex, massive hat tip to Alex. This is a tool to step through the layers within a Docker image. So each line in the Docker file adds a layer effectively, and you build it up. And there's some little catches in there that if you build some stuff up and then you don't delete it correctly, it can kind of accumulate. So this tool, you can effectively step through each layer and, I'm installing a JDK here. What does it bring into the file system? I'm installing my app here. Where am I touching the file system? It's a really nice way, again, to just understand a bit more about the artifact. The tool is called Dive. Well worth it. And as an example, I had to play around with, I think this is OpenJDK 11 a couple of months ago with Oracle Linux. And you can see in the top left there, I think the first one is the first line at the top there, 117 megs, is the OS itself, Oracle Linux. The second line is just installing some utils, and the third line is the JDK. And you can actually see on the next screenshot, as soon as I move down from the second layer to the third, that's actually some symlinks, but you get an idea of, that's an area I need to investigate. Suddenly I've got loads more files in this part of the operating system, that kind of thing. Really nice tool, so hat tip to Alex. Building in containers, the multi-stage stuff, this is about a year or two old now, I think, is really useful. So I mentioned before, you want to treat your container images as the single binary. Yeah. The pattern we used to have before we had multi-stage courtesy of Docker, or hat tip to Docker, was we used to have scripts where we had like a build container, which we used to spin up with test utils and kind of do all our tests. And we used to have a script that then lifted out the binary from that container image and put it into a runtime image. So I had a full fat OS over here, some test data, maybe running a JDK, and then the actual production image was a JRE, super lightweight Alpine. We used to have Alex Ellis actually created the builder pattern, and he kind of, there was some very cool ideas. With multi-stage, you can literally, if you see on line 1, we're using a Maven image. We're calling it as build. And then line 7, I'm doing my usual Maven build. And then line 7, I'm copying from build to actually the line 6 Docker image, if that makes sense. So yes, it's 2 images. We're building in the Maven one and sort of ultimately deploying into the Alpine image. But all my config is in one file. So for me, the single binary thing is still kind of valid because though there is two steps or multiple steps potentially for the build, the interesting thing is we only get one output, which we run all our tests on, the second, the multi-stage builds. Docker at, I think it was DockerCon last year, introduced something called BuildKit. This is still kind of early, but maybe worth exploring. There's some more fun stuff you can do with stages, with BuildKit. The performance is meant to be better when you're building rapidly, which is interesting. This is Docker stats, not mine. And there's some cool stuff they've done with context mounts. I think they've changed the name now. But effectively, it's a great way to do caching. And if any of you have tried to build Docker with Maven, say, in a Java app in a Docker container, you'll notice when you change dependencies, you blur away the layer, and then Maven downloads the whole world again. And if you keep changing dependencies, it's very easy to be downloading lots of Maven dependencies all the time. So with the caches here, you can effectively mount an external directory into the container while you're doing your dev loop locally, and it will do a best effort caching as well. All right? So that's quite a useful thing to play around with. The real anti-pattern I'm seeing is the differences between test and prod containers. Yeah? I've seen some folks, they create sort of a test version of a container, full OS, JDK, test tools, maybe a MySQL in there or a in-memory data store, and then they go and create a prod version of the container. Good intentions, totally, but it's very easy to see app configuration drift from what you think you're going to deploy and what you actually deploy. Showing my age, but I'm a massive fan of the Gremlins movie. For me, it's a little bit like the test container. You're sort of feeding the gremlin after midnight. Yeah, sorry, you're feeding the I've forgotten the name now. But what I'm trying to say here is, if you overfeed the test container, it's very easy to see a gremlin emerge. Yeah, so do think about these things. I totally get why folks want to do it, but I think the good pattern for this is have the one image that you're going to deploy into production, but use what's called sidecar containers to bundle other things. And be it if you're using Docker Compose or Kubernetes, you can often find ways of pairing the containers together. So there's a thing that ends up in production, your actual production image, and you might have like a secondary container with a data store with some test tools in it. If you're in Kubernetes, you put them in the same pod, for example. With Docker, you can bind them. There's various ways you can do it. I strongly advise against doing the test and the prod different containers. Just think of the gremlins. If you feed the test container too much, you will get a gremlin. Yeah. There's a whole bunch of clever patterns you can do with the multi-stage build. You can do like multiple kind of tests. So in the middle there, I've called it on line 6 as integration test. I've seen some files where they have kind of the building of the image up top, multiple stages doing various tests, performance tests, security tests, all that good stuff, and then a release at the end. And with BuildKit, you can do some kind of short circuiting. So if you just target to build the release, it will only build the dependent stages. So you can run all your tests in the pipeline, but if you're just looking to build the release, you can just target the end. In this case, because it copies from build on line 12, it will make sure that this is run before that as well. So the multi-stage thing is quite powerful. That's what I'm trying to say, really. A couple of deep dives into, or a couple of high-level bits around working remotely and sort of locally. I often find with microservice systems, you cannot run it all on your laptop now. So this is a slight aside to the thing. I wrote about this. I was working with an awesome company in London called Open Credo a few years back. My team and I, we kind of brainstormed, and we've shared some ideas on if you are starting to work with microservices, how do you mock effectively? How do you virtualize effectively? Because you probably can't spin everything up on every data store on your laptop. So it's all about sort of probabilistic kind of trade-offs, realism versus probability of kind of failure. Share some ideas there. One of the reasons I went to work with DataWire, fantastic tool called Telepresence. If you're in the space, it's an open source tool. It's a CNCF, a Cloud Native Computing Foundation tool now. If you're in the Kubernetes space, it's a great way to effectively proxy your laptop into a Kubernetes cluster. Nice two-way proxy. So I think I've got a blog post. Yeah, I have. Blog post where I was debugging using IntelliJ locally while I was working with a remote cluster. And Telepresence swaps out my Java app actually in the pod with a proxy, proxies all the traffic to my laptop and back, and I can just run my normal debug tools locally. Other tools do exist. Telepresence is not the only one. It's the one I use the most, obviously, because I work with DataWire. But this kind of stuff I find is very useful when you're dealing a lot more with bigger systems, and the systems are distributed and in the cloud, for example. To that note, Shahid, fantastic blog, hat tip to him. I've talked about this at a bunch of conferences. Ellen Corbs does a lot of great stuff in this space too. I can give you more links. But what we call the DevX, the developer experience, often alters with containers. I learned some lessons the hard way. These are some reference for you. If you are moving into the container space, be aware that your tool chain may alter, and there may be some slight snags compared to how you traditionally kind of do that in a dev loop of code, test, deploy, that kind of thing. So check out those references. Moving on, so the actual building and the storing in the artifact. One of the key lessons I learned in this space is metadata. Yeah, well, I think this, again, is almost slightly separate from containers, but I noticed it in particular. A whole bunch of security things popping up in the news, be it in the UK, be it in the US. Professional teams are targeting even small companies now, let alone state actors with the Googles of the world, for example. But a lot of problems originate with people not knowing what's running where. Yeah, and if you put stuff in a container, it's very hard to understand what you put in there sometimes. And microservices, people lean away from semver, they lean to git char, these kind of things. But what I'm trying to say here is there is mechanisms for containers for you to put all this metadata in the container. So if a vulnerability, a 0-day hits, you can use it as a kind of trace to understand what's deployed where. This, I think, is something I've learned the hard way. Particularly in a big company, it's knowing, when do we build this thing? What's the image name? Who built it? And you can also do clever things with like cryptographically signing images. So the QA team does their tests, they sign the container image, and then we can verify that before deploying the container into production. I'll give you a couple of tools in a minute. You can do that. But putting metadata in, you can use a build time labels. So Docker's got a very nice labeling system, namespaced, all what we used to in this sort of like with our Java imports, that kind of namespacing. A couple of tools there I was going to leave for you. Ross Fairbanks and the Microbadger team have done amazing work on giving advice around how to structure labels and what kind of metadata to put in your containers too. I often find I augment the build time with additional metadata. And Docker at the moment isn't very good, or it's not possible really to update the labels at runtime. If you do that, you create a new container, a new image, sorry. So that's not, it kind of breaks my single binary thing. So if you want to do testing and add additional metadata after the fact of the image being built, I've just stored the metadata in Artifactory or Nexus. Docker have got a couple of commercial products like Trusted Registry. Google have got some very interesting stuff called Grapheus and Critus. Excuse my British pronunciation. I'm not exactly sure how it's pronounced, but Grapheus or Critus. And they, in their GKE, their hosted Kubernetes offering, there's a way where you can cryptographically sign Docker images and ensure that only signed images will get through to production. So you can have the security team doing the tests with a key. They then sign the image. They hand it off to the QA team. QA team, if it passes, sign the image with their key. And you can say, only if these keys are present on the image does it actually go through to production. So hat tip to Google for leading the way in this. I think many other organizations will follow. This being able to verify what the container has been through, what kind of testing it's been through, and then deploy it is really quite powerful. Moving forward to the QA section now. So on what I advise is, definitely don't stop doing your kind of, your staging environments or whatever. But when you're moving to a sort of more container-based microservice system, if you can, try and do component testing. So try and say, if you've got to spin up, you obviously want to test unit testing, integration testing within your apps themselves. I'm not saying don't do that, but you probably want to test a few services together. Because now I find, microservices, to do something useful in a business context, often there's a couple involved. And again, things like Docker Compose in this example, Kubernetes, there's a few tools, Micro K8s, K3S by the Rancher team. They're like mini in-memory versions of Kubernetes, which you can spin up. You can deploy a sort of subsection of your app. You can then just run a bunch of tests against your normal endpoint, like an API gateway or just an API, for example, these things. So don't forget, standard unit, standard integration tests. Definitely do your pre-production testing as well, but I like to run some stuff actually in containers in a kind of lighter weight environment, and there's tools out there to do it. In particular, I love doing my load testing. It's not soak testing or not necessarily like sort of hardcore production style load testing. It's more of a case of watching for degradation of performance. I had a couple of projects where it was microservice based, and we only noticed a massive performance issue when something fell over the cliff. When we actually looked back, we'd been committing code to this one microservice, and it was teetering on the edge, and we committed one extra line of code, which completely destroyed the performance of that service, which destroyed the performance of our whole system. Now, if we'd been tracking the performance of that one service, like just running simple tests against the API, we would have seen the performance doing this, and we would have tried to fix it before it fell off the edge. Yeah? So I definitely recommend, if you've got like sort of very central, very important subsystems in your applications, spin them up, use something like Gatlings just to exercise them, and use, say, Jenkins or Circle CI to graph the performance of a kind of hot path through, or the primary path through the application, just to watch for trends, really quite key. Because Docker will alter the performance characteristics as well of the runtime environment sometimes. I'll cover some more security testing in a minute. Fantastic talk by Aaron Gratifiore. It's quite an old talk now, 2016, but I've learned most of my security stuff from Aaron. Yeah, so I'm not saying I'm a security expert, definitely not, but Aaron is, for example. He did the CIS benchmarks and the CIS papers. I wrote it up for InfoQ. Hopefully a useful jumping off point for you to give to your InfoSec team, or just for you to understand, like I learned a lot just about the new attack vectors introduced by containers, for example. Containers, they've got a lot better with security, but back in 2015, there were some definite gaps, but they've got a lot better. But that advice still stands. A lot of people talk about speed, so I'm just going to dump a sort of few things on the screen now. Migrating to the latest Java, I think, often helps, even if you're not using all the latest and greatest features. So Java 11 is the LTS version. I see a lot of folks having success with Eclipse OpenJ9. This is the IBM claim. I'm not going to substantiate it, but I put it up there out of interest. I have clients that have worked on that. People are moving to AOT, as the graph shows. JIT will give you the better performance, typically in the long term. But if you're spinning up apps in a container and destroying them, maybe AOT will give you more stable, good performance. Yeah. So, and things like application class data sharing, where you kind of load up all the class files and then save it to a special file, so you don't have to next time parse all the class path and reload it in, can really cut down boot times. So do check these things out. But again, from my perspective, whatever you do on these kind of shortcuts, these tricks, do test the app, because they can change certain things. Do it, test it in your pipeline. Stability, I had a couple of classics actually in 2015, I think it was, we were working on this. There's a whole bunch pre-Java 8 update 131. It was fixed in actually Java 10 and then backported. The JVM didn't respect or didn't see properly the number of CPUs on the host. So what example we had Amazon boxes with like 64 cores in them. We only gave each container a couple of cores, and the runtime is clever enough, it's enforced, so each Java application running on this massive Amazon box only got the processing power of a couple of cores, but the JVM looked at the host and thought it had 64 cores to play with. Yeah? So when the JVM boots up, it goes, oh, I've got 64 cores on this host. It does the GC threads, the default fork join pool. Nothing really breaks, but the performance is a bit wonky. Yeah? Because when it tries, its algorithms optimize them for 64 cores, and it's only got access to 2, it goes a bit strange. This has been fixed and backported, but if anyone's running like JDK 6 or whatever, be aware that you may have like subtle weird performance issues in this respect. I made a bunch of mistakes with memory. Do recognize like the heap size, permgen, metaspace, whichever version of Java you're running on. Do size appropriately, or your apps will be getting killed within Docker, within the container OS. So I had a bunch of weird things where we set like 10% overhead on the heap size, and we had a very thread-intensive application. It was creating a lot of threads, and it was burning through native memory, because each thread requires native memory in addition to like heap size, heap space. So we learned some lessons there. Your mileage may vary. You have to test, basically. If you've got a very thread-intensive app, you may need to give it more memory. And the last and the weirdest one was entropy. So now with these massive Amazon boxes, 64 cores, 32 apps running on it, they were freezing. It was a Spring Boot app. We couldn't figure out what's going on. It was running production for a while and freeze. Eventually, we figured out it was only freezing on cryptographic operations, token generation, sign-on, that kind of thing. We caught it. We managed to step through the whole stack trace, and we figured that it was, literally blocking because dev random was blocking. Yeah, the actual OS, if you like. And it's because when you're running all these apps on this box, there's very little entropy. The system uses entropy to generate randomness. And on a normal machine, if you're banging the keyboard and the network ports, the system's very clever at capturing that as randomness, as entropy. But you've got these boxes in the cloud with all these apps running on them. The entropy is quite small, and it gets exhausted really quickly. So what we did is we switched to dev urandom. And urandom on the operating system is a pseudo-random generator. It never runs out of randomness. There is subtle differences between urandom and dev-random. I put some notes on this. I'm convinced that for the majority of cases, dev-random is the way to go. There is some folks that are not convinced, so I wanted to present both sides of the argument. I've got a hat tip to, is it Andy or Matthew? I think it's Matthew Gilliard. I learned a bunch. He's done an even more in-depth talk on this in the past. He proper deep dive into all the weirdness. Most of it's been fixed now, but if you're running old JDKs, you might bump into some of these things with Docker, for example. Right, looking pretty good for time. Final furlong is with security. So did a whole chapter in the book on this because I think it's really important. And by coming to Code 1, you're pretty much saying you're a professional, or you're an aspiring professional in software engineering. And I think we as an industry need to take more responsibility for this stuff. Yeah, I'm not going to get on my soapbox too much, but I think we as engineers, we are starting to be legally held accountable now. I think that's a good thing, but we need to step up before we get regulated by other government entities, those kind of things. So basic stuff, do you want to like find sec bugs, awesome static analyzing tool. It's caught a bunch of things on code I've worked on, like using random in Java wrong, people doing CLI injections, SQL injections. It's a static analyzer, so it only captures patterns of code, but it's very good as a sense check. Chuck it in Maven, chuck it in Gradle, you're all good. Gives you a nice report as well as to things it might have found. Your code is really important to check, but obviously you're bringing in lots of dependencies too. Yeah, like most dependencies, particularly in open source, are written by people like us. So we all make mistakes, yeah? So it's worth double checking other folks' code. Various ways to do it. I like to use OWASP dependency check. SNCC is a very good commercial tool. I've got no affiliation, but I like their products. But when I'm using open source, I use OWASP dependency check. It's literally a 10-liner in Maven. We had a Spring Boot app, which we left. We didn't deploy into production. We left it, I think, for 3 months. We ran the build again, and we spotted, I think it was 5 new vulnerabilities in the app, just in 3 months. We bumped the versions of all the offending dependencies. There's a logback dependency, some other dependency, XML vulnerability or something. We bumped all the versions, the latest versions, and all the dependencies went away. All the vulnerabilities went away. We were more than happy to have these 10 lines of code in our POM, yeah? Because that could have been an exploitable kind of vulnerability. Nice tool there if you do want to scare your management as well. You can go, look at this, all these scary things, and then we need to fix this, which I find is quite useful. So if the carrot doesn't work, use the stick of Maven reports. There's a technique there. And of course, on the topic of this today, container images add another layer on top. I've used Claire a whole bunch, open source container scanner. It scans the OS effectively for things like Heartbleed and Dirty Cow, all that kind of random stuff that you see online. Claire was part of CoreOS's offering. Docker, Amazon, all the big names now have got commercial scanners, which I highly recommend paying for. Money well spent, in my mind. If you want to go open source, there's Claire. Running it's a bit awkward. I'm not sure if it's maintained that well now. So the only thing worse than running not running a security tool is running an unmaintained security tool. Yeah, so do check that. Armin, hat tip to Armin. He actually created an open source project that bootstraps the Claire scanner in a container. So you get the inception thing going on where you've got a container in a container where you can scan a container. It's all very good stuff. But again, the actual Claire project, I haven't done my due diligence on of late. I've been using Aqua more late. The commercial offering, fantastic. You do have to pay for it, of course. The free version gets me along quite a long way. The free version is invasive because you have to put a run line. You have to get a token from them, and you have to put a run line in to scan your container. Not ideal, but more than enough to get you started and get you looking at their products. Just an example, so I did a scan on, it was OpenJDK 8 about a few months ago. There was a couple of vulnerabilities. Apologies if you can't see. It was 2 vulnerabilities, one high, one medium. I then fired up an older version of the JRE, so same kind of config, but just an older version. It was only, at the time, a year older. So the client was running a much older version, actually, of the JDK. But just in that year alone, the number of vulnerabilities had increased from 2 in this modern version to 10 in this 1-year-old version. And there was 3 high vulnerabilities. So again, every layer of the system these days you need to think about. Yeah, really, really important. I get quite a lot of pushback in agile environments saying that we don't think about scalability and we don't think about security until the last responsible moment. Now, I like the concept of the last responsible moment. Particularly if you're building features, you want to get as much information as you can. You make the decision before it's irresponsible. Learn as much as you can. There's a fork in the road. You decide which fork to go. For building functionality and building features, that last responsible moment totally makes sense. Learn as much as you can. But the news flash for things like performance and security is sometimes the last responsible moment is up front. Yeah. I have a real hard time with clients. I say, what's the security profile here? And they go, oh, yeah, make it secure. I'm like, yeah, no, but what is it, like a government-backed system? Is it mom-and-pop store? What's the deal here kind of thing? I have to push a lot. Modern platforms, things like Docker, Kubernetes, modern architectures, where we've got more things in the mix, more languages potentially, don't make this easier. And I think it's very easy to get the whole broken Windows thing sometimes, yeah. Show me to fix it right or fix it fast. Yeah, we'll just fix it fast. It goes downhill pretty quickly. Yeah. Hopefully perfect to time there. So in summary, a few things to take away. Docker and Java, great combination of technology. Do understand with anything in the mix here, things change. We as engineers need to take responsibility and adapt. Yeah? Continuous delivery, I think, is essential with the pace and the security and the stability challenges we as an organization, we as an industry have. Container images are now your single source of truth. Build them early, build them once, test them in the pipeline. That's the key thing, message today, really. Having sort of metadata for provenance and validating NFRs of builds is vital. Respecting your team that not all developers are operationally aware. It's not a problem. It is what it is. We need to design the organization accordingly or train people accordingly. That's what I'm saying. Recognize where you're at. Recognize where you want to get to and put steps in to get there. The shameless plug again, but the book does kind of give a whole chapter on how to do that kind of stuff. So, please support my kids through college, I think. We're really good there. But yeah, please do check out the stuff. You're welcome to get in contact with me on the interwebs. I'm pretty busy, but I try and respond to everything. So love to chat to folks online as well. So thanks for your time today. Appreciate that.
Hi, I have a question.
Yeah, sure.
So one of the topics was using modules to reduce the size of the content.
Yes. Sorry,
Size of the image.
yes.
And do you, it may be different from your topic, do you use modules?
Like Java modules?
Java modules.
Not much, to be honest. Not as, I think it's definitely a thing that's up and coming. It's becoming more accepted. But the vast majority of applications where I'm working.
So, two questions about that. It looks like a light is mounted. You can mount it. You can move it wherever you want. If you don't like where it's pointing, you can mount it. Like I find it set